Hey everyone, welcome back to Singularity Today. Atom Infinity here, and today we're diving deep into some fascinating research papers that are pushing the boundaries of artificial intelligence and its potential impact on our world. From making neural networks learn faster to revolutionizing how we interact with virtual reality, we'll be exploring groundbreaking developments in fields like machine learning, medical imaging, and human-computer interaction. So buckle up and get ready for a journey into the future of technology. In accelerating training with neuron interaction and nowcasting networks, the researchers explored a way to speed up the training of neural networks. Think of training a neural network like teaching a dog a new trick. It takes time and repetition. This research proposes a new approach called NENO networks, which use the connections between neurons in a neural network to predict future changes in those neurons. This is like watching a dog perform a trick and then predicting what they'll do next based on how their body is moving. By predicting these future changes, NENO can make the training process faster. The research found that this approach can speed up the training process for certain types of neural networks, like transformers, by up to 50s. This could have a huge impact on fields like computer vision and natural language processing, where faster training means faster development and more efficient algorithms. Imagine developing a new voice assistant that learns much faster, or a self-driving car that can adapt to new situations quickly. This is the kind of potential that NENO holds. In the research titled A Survey on Knowledge Organization Systems of Research Fields, Resources, and Challenges, the authors delve into the world of knowledge organization systems, COS, which are like libraries but for academic research. These systems use things like lists, dictionaries, and taxonomies to categorize, manage, and retrieve information about different research areas. The research looked at 45 different costs used in various academic fields, analyzing their scope, structure, how they're maintained, how they're used, and how they connect to other costs. They found that these systems vary greatly in size, quality, and how they're used, highlighting the need for more integrated solutions that work together across disciplines. This research is important because it helps us understand the current state of knowledge organization in academia and points out areas for improvement. This can have a big impact on how we search for and analyze research information. Imagine a system that can easily connect research papers, experts, funding sources, and even software tools related to a particular topic. That's the kind of thing that these more integrated solutions can make possible. In the research titled Hybrid Spiking Neural Networks for Low-Power Intra-Cortical Brain-Machine Interfaces, the authors are tackling the challenge of creating more efficient and portable brain-machine interfaces. MIS have the potential to help people with paralysis regain control over their bodies, but current systems are bulky and require lots of wires. This research explores the use of hybrid spiking neural networks to decode brain signals and translate them into movements, potentially paving the way for smaller, wireless, and more advanced MIS. The hybrid networks are specifically designed to be energy efficient and process information from a large number of brain neurons. The researchers found that their approach successfully decoded the movement intentions of monkeys, achieving impressive accuracy while using fewer computational resources than existing methods. This could lead to breakthroughs in the development of next-generation neuroprosthetic technologies, enabling people with disabilities to regain lost motor functions with more intuitive and seamless control. In the research titled RLPF, Reinforcement Learning from Prediction Feedback for User Summarization with ELMS, the researchers present a new approach called RLPF to improve user personalization systems. that use large language models. This approach aims to address the issue of noisy and lengthy user data by generating concise, readable summaries that are still informative and useful for downstream tasks. The RLPF method works by fine-tuning ELMs to produce summaries that maximize their usefulness in downstream tasks. This way, it effectively distills large amounts of user history data while preserving important information. The research shows that RLPF significantly improves performance on downstream tasks, up to 22 improvement, and also produces summaries that are more factual, abstract, and readable than those generated by existing methods. RLPF also has the ability to shorten user history data by 74 while still maintaining good performance on new tasks and datasets, proving its flexibility. This research has the potential to make user personalization systems more effective and efficient by providing a better way to handle large amounts of user data. The technology can be used in various applications such as e-commerce recommendations, social media personalization, and targeted advertising. Imagine a personalized shopping experience where your past browsing history is summarized into a concise and relevant summary, leading to more accurate recommendations. RLPF could also be used to create personalized news feeds or social media feeds that are tailored to your interests. In the research titled Improved Parallel Algorithm for Non-Monotone Submodular Maximization under Knapsack Constraints, the authors tackled the problem of finding the best possible combination of items from a large set where each item has a value and a cost, and we have a limited budget to spend. The goal is to maximize the total value of the selected items without exceeding the budget. This type of problem appears in various fields like advertising, image processing, and social networks. The research proposes a new parallel algorithm that significantly improves the performance of existing methods. The algorithm cleverly splits the problem into smaller subproblems, solves them in parallel, and then combines the results to achieve a better solution than before. The research shows that the new algorithm achieves a better approximation factor compared to existing parallel algorithms, meaning that it gets closer to the optimal solution. This improvement in efficiency can be beneficial for various applications, allowing for faster and more effective decision-making in resource allocation and optimization tasks. Imagine you are planning a trip and need to choose attractions to visit within a limited budget. The algorithm can help you find the best combination of attractions that maximizes your experience while staying within your budget. The potential impact of this research lies in its ability to address complex optimization problems more efficiently, paving the way for better solutions in various fields. In the research titled OpenMadeVit 2, an open-source project toward democratizing autoregressive visual generation, the authors present a series of image generation models that are open source. These models are designed to create images based on a specific set of instructions or prompts. The key innovation is the use of a tokenizer that allows for a very large variety of details to be included in the generated images. The researchers were able to achieve state-of-the-art results in image generation quality. The researchers also explore ways to improve the efficiency of the models for generating images with complex details. By releasing the code and models publicly, the researchers hope to encourage others to build upon their work and advance the field of image generation. This research has the potential to impact many fields, including gaming, design, and marketing, by enabling users to create high-quality, realistic images without the need for specialized expertise. In the research titled Case Forward human-centered interaction and forward-scene capture in large-scale space using wearable EMOS and LiDAR. The authors present a new method for capturing dynamic environments with people in them, making it possible to create detailed virtual reality experiences. The method, called Hishford, uses a combination of sensors like inertial measurement units (EMUS) that are attached to the body and a LiDAR scanner on the head to capture both the environment and human movements in real time. The researchers also created a large data set of real-world scenes with people doing everyday activities, which can be used to train and test new virtual reality technologies. This kind of accurate and realistic 3D capture of people and their interactions with the environment could be used to create many new virtual reality applications like interactive training simulations, realistic virtual tours, and even video games that feel more lifelike. In the research titled question, Answering Dense Video Events, researchers tackle the challenge of answering questions about multiple events happening in long videos. This is different from existing methods that focus on single events. To achieve this, they created a new dataset called DevK, containing thousands of questions about events in long videos. They found that existing AI models designed for single event questions don't work well on this new dataset. To overcome this limitation, they propose a new method called DV. DV helps AI understand and answer questions about dense events by using a special captioning module to detect the events, a memory module to remember them, and a self-consistency module to make sure the answers are accurate. Their experiments show that DV is much better at answering questions and identifying the relevant parts of the video. This is a big improvement compared to existing AI models. This research has the potential to improve how AI understands and interacts with videos. For example, imagine asking your virtual assistant to summarize a long movie and provide highlights. This technology could make that possible, enabling a deeper understanding of video content. In the research titled The Impact of Scanner Domain Shift on Deep Learning Performance in Medical Imaging, an experimental study, the authors investigated how well deep learning models trained on images from one medical imaging scanner can perform when applied to images from a different scanner. This is like training a model to recognize different types of cars using photos from one camera and then testing its performance on pictures taken by a different camera. The research found that the performance of deep learning models generally drops when used on data from a different scanner. This drop was most significant for MRI, moderate for X-ray, and minimal for SET, suggesting that CT systems are more standardized than MRI or X-ray. The research also explored strategies for improving the model's ability to work with images from different scanners. This research is important because it highlights a significant challenge in applying deep learning to medical imaging. The results can guide the development of more robust deep learning models that are less affected by scanner differences. These models could be used for a variety of medical imaging tasks, such as diagnosing diseases or planning treatments. In the research titled Provable Hyperparameter Tuning for Structured Pfaffian Settings, the authors explore how to provide theoretical guarantees for data-driven algorithm design, which is a way to automatically adapt algorithms to specific tasks. This is a bit like having a robot that learns to play different games, like chess or video games, by watching how other people play and then figuring out the best strategies on its own. However, proving that the robot will always play well, even when facing new challenges, can be tricky because its strategies might be complex and change depending on the situation. The authors created new tools, like the Pfaffian GJ framework, to analyze and prove guarantees for these data-driven algorithms, particularly those involving Pfaffian functions, a type of mathematical function that allows for more complex and flexible behavior. They found that many important algorithms have a special kind of piecewise structure, which their framework can use to provide guarantees. This research opens the door to creating even more powerful and reliable data-driven algorithms that can tackle difficult problems in various fields like machine learning, robotics, and even optimizing logistics or financial models. All right, folks, that's a wrap on another mind-blowing dive into the world of artificial intelligence. Hope you enjoyed this glimpse into the future of technology, all thanks to the tireless efforts of some seriously brilliant researchers. But hey, don't just take my word for it. Check out these research papers for yourselves and let me know what you think. And remember, you're watching a video created entirely by a computer, so you can relax and enjoy your day, knowing that no humans were harmed in the making of this content. Don't forget to like, subscribe, and leave a comment below. It really helps the algorithm, or whatever you call it in the digital world. See you in the next video, where we'll explore more cutting-edge research and unravel the mysteries of the singularity, one bite at a time. Until then, keep your brain sharp and your curiosity alive. Peace out.